Okay, here we are. So Amazon Leo is their competition to SpaceX's Starlink. It's a on-orbit internet provider. So this will be the last flight of this configuration of Atlas 5.
while keeping the 29th spacecraft safe from the harsh atmospheric conditions. On the fairing, we are proud to display artwork from Amazon's Leo program in its signature Krypton color, along with the American flag and the Atlas and ULA logos. The Amazon Leo name is a nod to the low Earth orbit constellation that powers this network. And if you look closely, you'll notice the logo includes an aurora shaped by the letters LEO.
So
As we continue the countdown, let's take a closer look at how ULA builds the Atlas V rocket.
Amazon was supposed to have half of the constellation up by the end of this month,
Engineered in
July
Centennial,
31st.
Colorado, ULA's Atlas
Um,
V.
I'll need that. I'm not sure if I'm doing this right, but anyway, they only have a couple hundred. They needed 1,600 and some odd satellites up, or whatever, and they were risking losing their license because the FCC requires, that they're basically reserving this bandwidth for these satellites, and that bandwidth is very valuable. Plenty of other companies would love to have it. So if Amazon can't get their satellites up into orbit, the FCC would just say, hey, let's let someone else have this bandwidth. So they basically lobbied the FCC to give them more time. FCC said no originally. But what they went ahead and did is they got rid of this 50% uh, milestone requirement. They still have to get all 3,000 up by the end of July or the end of May, somewhere around there in 2029, 28, at least 2028. No, 29, 3 years. Um, but in the meantime, any satellites that are launched after the end of this month are not allowed to have top priority on that bandwidth. They have to allow other people to use it um, until I believe it's March of 2028. Um, that requirement will expire, or if they can get their 50% of the satellites up before that, then they'll basically have full rights to that bandwidth. So they're not doing well. The Amazon shareholders had to threaten to sue Jeff Bezos because he refused to launch any satellites on SpaceX. And so Jeff Bezos actually went ahead and purchased some launches on SpaceX Falcon 9, which are about half the cost of this launch. This is $150 million a launch, and they're capable of launching satellites on Falcon 9 for about less than I think it's about 80 million or 60 million. It's much cheaper, but the shareholders had to threaten to sue Jeff Bezos for financial malfeasance, basically failing to do what was in the best interest of the Amazon shareholders, which he's required to do by law.
T0 time to 12:30:15 a.m. Eastern Time.
Okay, so they have a T0 that's basically 9:30 Pacific time where I'm at. This is about 20 minutes from now.
LC. Go ahead. Transfer dispenser battery to flight mode. Roger.
LC Fuel 2.
Go Fuel 2.
Centaur LH2 has been above 99.8% for 5 minutes.
Roger. PNA2 for Centaur LH2 SCP cycle test.
Roger.
T-minus 4 minutes and holding. This is a programmed 30-minute hold.
LC switch not ready. ALC LC.
Go ahead.
Please set for a new T0 of 043015.
In work.
LC Prop 1.
No problem.
Per step 780 fuel fill sequence is complete and start bottle fill nominal.
Roger.
LC Fuel 2.
Go Fuel 2.
Centaur LH2 is at flight level.
Roger.
LC, ALC.
Go.
Countdown clock has been set with a new T0 of 043015 Zulu. Currently at L-minus 17 minutes and counting.
Roger. All right, team, we have an approved new T0. Clocks are set and tracking.
LC, ALC.
Go.
Countdown clock has been set with a new T0 of 043015 Zulu. Currently at L-minus 17 minutes and counting.
Roger. All right, team, we have an approved new T0. Clocks are set and tracking.
So it sounds like they just synchronized their T clock and L clock. L clock basically is the clock for their launch window. They try to set a
SCI.
T0 time within that
Dispenser
L
battery
clock.
in flight mode.
Roger.
So when they synchronize those two clocks together, that's a good sign that they're
LC,
go for launch.
PNA2.
Go PNA2.
For step 720, Centaur LH2 SVV cycle tests are complete.
LC,
Roger.
SCI.
OSLC. Go.
Dispenser battery in flight mode.
Go.
Roger. From data transfer to backup CCLS. Roger.
The LEO 8 mission will deliver another 29 Amazon LEO satellites to low Earth orbit. Identical to the payload integration of the last 3 Atlas V LEO missions, the team added a 4th level to the satellite dispenser system, allowing for more satellites to fly on a single launch and further accelerate deployment of the constellation. This was all made possible by engineering work between Amazon Leo and ULA
Amazon
to use
Leo
additional
and
performance
ULA
from the
to use additional
RL10C
performance
upper
from
stage
the RL10C
upper stage engine. Around the world, billions of people still lack access to high-speed
Amazon Leo
internet.
is working to deliver
Amazon
fast,
Leo is
reliable
working to deliver
internet to
fast,
customers and
reliable
communities
internet to
beyond the reach
customers
of
and
existing
communities
networks.
beyond the reach of existing
Let's
networks.
take a closer look.
Let's take a closer look.
So we're about T minus 14 minutes to launch. It's 12:30 a.m. in Florida, and inside the fairing there are 29 satellites for Amazon. Um,
As we
they
approach
haven't started their
America's
service yet.
250th anniversary, we want to hear from you in the live stream chat. How are you celebrating the 4th of July? At ULA, we are lucky to have the opportunity to be part of a variety of missions that make our country more connected and safer.
I don't know what happened. I just lost the feed for them for now. But anyway, Amazon has not started the service yet. They don't have enough satellites up there to do that. They think they can probably offer some like better than nothing service when they get 500 satellites up. They have a couple hundred up right now, so they got a ways to go. Um, their service is not going to be quite as good as Starlink. Well, it's going to be 3,000 satellites versus Starlink is over 10,000 right now, and they're at a much lower altitude, which creates faster latency or lower latency time. So Amazon Leo is almost twice as high in the altitude, so your latency is going to be a bit longer. So SpaceX is pushing to get latency below 20 milliseconds, and looks like Amazon might be double that, but they're planning on offering a service at a cheaper price. So we'll see how that goes. I wish them a lot of luck, but I don't see this business working out too well for them. Um, SpaceX is already on dozens of airlines. You get Starlink internet on onboard airplanes, cruise ships. Um, I forget how many airlines it is, but it's a lot. Delta Airlines is the only major carrier that's not running Starlink right now, and they said they're holding out for Amazon. They're going to be waiting a few years, um, and that's just not good. The internet was just absolutely roasting the CEO of Delta for being this dumb. And I think a few days later, after all that was happening, um, uh, Blue Origin had their explosion of their then rocket, which they were really counting on to get these satellites up in a much faster cadence. So that's been a huge setback. Blue Origin's hoping to get back to flight by the end of this year, but they had to rebuild, or they have to rebuild a bunch of their launch complex that got destroyed in the explosion. They lost one lightning tower. The transporter erector was destroyed. They were planning on retiring that anyway. They have a backup for the new thing that they're going to use for that anyway. Fortunately, their fuel farm wasn't destroyed, and they say the repairs are pretty minimal, but it was a huge explosion. If you haven't seen it, I definitely encourage you to go and check it out. Um, Again, this is Amazon Leo. It used to be called Project Kuiper. Um, that's their space-based internet service provider. The They're going to be operating at 98 different orbital planes. So each string of satellites will circle the Earth. That's one orbital plane, and then they have different orbits at different angles. And so there are 98 different planes. There are three different altitudes or shells, and those are at 590 kilometers, and then 610 kilometers and 630 kilometers. The FCC is requiring that they have all three, I think it's 3,200 and something satellites on orbit 3 years from now. They were supposed to have half of that up by the end of this month. That's not happening. They were able to get kind of a pseudo extension, as I mentioned earlier. For ULA, this is the 110th mission for the Atlas V rocket. This rocket is being retired. This is the last flight of the Atlas V in this configuration, which is the 551, which means there's five solid rocket boosters strapped on the outside. It's got a 5 meter fairing, and what's the one for? I think that's one engine on the second stage, or something like that. This is ULA's 174th mission total, the fifth one for 2026. So this is the 5 launches so far this year. And for all of 2026, all companies and nations combined, this is the 157th orbital launch attempt. There's been a few failures in there, but most of them made it to orbit just fine. So ULA's contribution to that number is very small and rather disappointing. It seems that they're not able to keep up with the rest of the world. SpaceX obviously is like 80% of that number, and then China is second place. ULA has their Vulcan Centaur, which is replacing this system, but its launch cadence is even slower. But hopefully they'll turn that around. The CEO of ULA, the old one, Tory Bruno, he was kind of the leading force for the company, made him a huge success. He bailed on the company last year, and he now works for Blue Origin. I don't have the exact orbital inclination of this launch. I'm trying to find it. The cost of this launch is $153 million. So as I said, that's significantly more expensive than the SpaceX launch, which for Falcon 9 can go as low as $60 million. The Falcon Heavy can anywhere from 90 to 100 million. So it looks like we're about. Oh, it looks like everything froze. Hold on. Try to get that restarted.
Tracking systems are ready. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go Amazon Leo. The final status check for the rocket and payload. In the final seconds, the power deluge system will activate, followed moments later by booster engine ignition. Then, after liftoff, you'll hear ULA's flight commentator Britt Porcelli providing live updates as the rocket ascends into space.
That's their mission control in Denver, Colorado.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments. These planned holds allow for the team to work through any issues that may occur during the launch count.
So yeah, this is the L- clock on display there. So L- 4 minutes. They have a 4-minute hold that they're in right now. So that's holding the T clock, not the L clock. The L clock continues counting.
2, 1, mark.
Okay.
359. 355.
Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 12:15 a.m. Eastern. After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
So the countdown clock, when they say that, they're talking about the T clock.
Following final confirmation of rocket readiness, the RD-180 engine, 5 solid rocket boosters ignite to produce more than 2 million pounds of thrust, lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. Amazon's LEO satellites are encapsulated inside a 5-meter diameter payload fairing, which provides protection to the spacecraft during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. ULA's high-performance Centaur, with its RL-10 engine, ignites, powering the upper stage and spacecraft into a circular low Earth orbit. The first burn comes to an end with engine shutdown. Centaur then rotates into the precise position to release Amazon's LEO satellites, spacecraft that will deliver fast, reliable internet to customers around the world.
140. 137.
Launch enabled.
Okay, so about a minute and a half. There's still some L clock on there, but they synchronize the
T-minus 90 seconds. The launch vehicle, ground systems, payload, and Eastern Range are go for launch. For those of you just tuning in, good morning. I'm Abby Katwar with today's live coverage of ULA's Atlas V Leo 8 mission. At this time, the team is not working any issues, and we are proceeding towards liftoff at 12:15 a.m. Eastern.
One minute.
T-minus 1
Rocket
minute.
report range status.
Range green.
I'm going to go through probably their final call outs here. The flame you see there on the left is a flare stack that's just burning off excess fuel.
40.
Stable at step 3.
$28.
Verify ECS. Reduce for launch.
Verified.
Status check.
Go Atlas.
Go Centaur.
Go Leo.
Final goes launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1. And liftoff of the United Launch Alliance Atlas V rocket, carrying another 29 satellites for Amazon Leo. These spacecraft will deliver fast, reliable internet to customers around the world.
RD-180 throttling down per flight program. Pitchover maneuver is now complete. Roll program is now complete. Mach 1, Atlas V is now supersonic. RD-180 throttling back up as the vehicle approaches max Q.
You are hearing the voice of ULA's Britt Porcelli providing
Max
launch
Q,
vehicle
the
set
vehicle's
data.
just experienced max dynamic pressure predicted for today's flight.
In about 15 seconds, the first stage engine will throttle down to
Traveling down the
prepare
center
for
of the range
separation
track now.
of the solid rocket boosters.
The
Main
primary
engine
reason
is
they're
throttling
returning
back
this
down
vehicle
in preparation for SRB burnout.
is those RD-180 engines are made in Russia. And
The
after
vehicle now weighs
Russia's
half
invasion
of its original
Ukraine,
liftoff weight.
the Biden administration
This is Atlas
SRB
Mission
burnout
Control
has
at L plus 1 minute and
basically
38
required
seconds. We are coming up on burnout and
all
jettison
U.S.
of the
launch
solid rocket
providers to
boosters.
only
These
use
additional
American
motors
parts.
increase the thrust at liftoff, giving Atlas an extra boost off the pad.
And positive indication of all 5 separation of SRBs. Guidance initiated. The vehicle has entered a closed-loop steering program.
I guess just American parts, but they're not allowed to use Russian parts. So one of the best engines ever made.
We are just
made.
over 2 minutes into flight. Next, the Atlas V rocket will transition to closed-loop steering, meaning it will use real-time flight data to adjust its path. One thing many people don't realize about launch day is that these key milestones are pre-programmed into the rocket's onboard computer, also known as its avionics system. While it may seem like engineers are commanding each step in real time, that work is done in advance and tested in ULA Systems Integration Lab in Denver. On launch day, the team is focused on monitoring the data coming back from the rocket to make sure everything is performing as expected.
Holding steady in preparation for PLF jettison. RCS pyro valve.
This is Atlas Mission Control at L plus 2 minutes and 52 seconds. In just a few moments, we'll have jettison of the payload fairings.
The vehicle now weighs 1/4 of its original liftoff weight. Confirmation of payload fairing separation and jettison, as well as CFLR deck jettison. RD-180 throttling back up as expected. One minute to BECO. RD-180 has begun throttling down to maintain a constant acceleration for the remainder of the boost phase.
We just heard Britt Porcelli confirm payload fairing jettison. The composite fairing protected the spacecraft as it pushed through the harshest parts of Earth's atmosphere. As we wrap up our live coverage, I'd like to say thank you for tuning into our early morning flight and remind you to visit ulalaunch.com. Follow us on.
So they're pretty much out of the atmosphere, so they were able to jettison those fairings because it's just extra weight. And so they jettisoned those, and they're not going to show us deploying the satellites because they don't like doing that. I don't know why. Here's a replay for you. Yeah, so those RD-180 engines, Russian made, very, very good. They're one of the best engines ever built. And that's what ULA was relying on for the Atlas V. The Atlas V was built around the engine. So rockets are normally designed around the engine. They come up with the engine and they design the rocket engine. So it's not like they could just put a different engine on this rocket. So, as you know, or you may not know, the Atlas platform has been around for like 5 decades. The Atlas V has been flying for a long time. So they basically decided to finally upgrade, and they come out with the Vulcan Centaur, which is kind of been having some troubles. But hopefully they'll get it worked out. And all right, they're not going to show anything. This is kind of a dud webcast. Anyway, that's all I got. I just wanted to. This is my first time doing a live stream that's actually been somewhat successful, so I'm just going to learn everything. But thank you for watching. I'm going to try to do more of these in the future, so feel free to give me a like, subscribe, and post any questions or comments, and I'll try to get to. Oh, here's some coffee or some shit. Vinegar. All right, cool. So anyway, hope you enjoyed. Maybe you learned a few things. Cool. Anyway, thanks for joining us.